Alright, so here's our logarithm 2.9 review. And let's go ahead and we'll step right into problem number 1 here. So the key thing you want to remember about logarithms is that if you have an exponential, the form y equals b to the x power, then by definition x can be written as log base b of y. So there's the conversion that we'll be using throughout this. And so when I look at this logarithm right here and I'm supposed to rewrite it as exponents, there's my base, there's my exponent, there's my argument. Now what you want to get used to doing, because this works are really helpful for your inequalities, is just bring your argument straight down. Your base is what you write on the other side, and that is to the negative 2/3 power your exponent up here. Just like that. And this is just a true statement. It's like taking an equation that says, y equals 4 to the 1/2 power and rewriting it as y equals the square root of 4. Okay, it's an equivalent statement just written in a different form. Alright, and we're done with that problem. That's all we had to do. Let's go to problem number 2. Problem number 2, we're going to do the same switch. Now my base here is 10, so I'm going to drop down my argument, 10,000 equals my base 10 to the 4th power. And I'm done. Now I'm going to logarithmic form. To go to logarithmic form, we kind of have to arrange things a little bit different. There's our argument right there of the logarithm. There's the exponent, and here's our base right here. So this is really log base 49 of our argument, which is 7, is a half. And all that's saying is that 49 to the half power is equal to 7, which means the square root of 49 is equal to 7. Here we got a nice negative exponent, but that doesn't affect us. Alright, let's do log. Now what's our base here? Okay, so right away we look at it and go, well, the base is 2, so we use a base of 2 of 1/8 equals the exponent negative 3. Problem 5, without using a calculator, find the value of the logarithm. So now it's like, hey, I don't know what it equals. So we just say, hey, 64 is 4 to what power? That's what that's asking. To do this, we equate bases. So we rewrite 64 maybe as like an 8 squared. Alright, 8 is like 2 cubed squared. Now I could have just known maybe right away that 2 to the 6 is equal to 64. But right here I can see 2 times 3 is 6. So I can rewrite this as 2 to the 3 to the 2nd power. So there's my 2 to the 6. Equals 4 to the y power, but I want that as 2. So I write it as 2y like that. Now I can go 6 is equal to 2y. So if my bases are equal, my exponents must be equal. Now I can solve that and find out y is equal to 3. Probably could have done this way easier. I went all the way down to base 2. So much quicker. This happens. 64 equals 4 to the y. I should have just recognized that as 4 cubed equals 4 to the y. Now I could equate exponents and I get y is 3. I flip-flopped it there, but 3 equals y, so y equals 3. Problem 6, I got log base 10 here, so it's asking 10 to what power? I'll write my y there. Equals 100. 10 to the y equals, this is 10 squared, so y equals 2. Use a calculator to find the value of the logarithm, so I'm going to pull out my trusty calculator here. It's a little too big for us. Alright, so a couple ways we can do this on our calculators. I'm going to use math, and I'll arrow way down to, where's my logarithm is at? There he is, A down there. Log, and I can type in the base of 7. I can type in my 145 like that and just hit enter. And tell me to 3 decimal places, it says. Let's do this to 3 decimal places. I'd go 2.55, and I'd round that 7 up to an 8. But the alternative way to do this would be the log of 145. I'm changing it to a base 10 logarithm. I usually don't write the base 10 though. Okay, but it's the log of your argument over the log of the former base that you were in. And I could calculate that on my calculator, but now I don't have to go hunting through all of my different features of the calculator. I can just type it in like that. Oops, hit delete on that guy and hit enter. There we go, and we'll get the same number. So either way you want to do it, I prefer probably this change of base formula, because that can be more useful in other situations. So I like to remember it. And not every feature or every calculator has that change of base option on your logarithms. Problem 8, same deal here. So you're going to see me on my calculator. Oh, this one's already log base 10, so this one I don't have to do anything to. Log of 9,843, we just type it in. Just round him off, that's 3.993, because they want 3 decimal places. For the given data, construct a plot using logarithmic scale. So each one, be sure to label S as scale. We want to do a base 2. So we're going to write these things as 2 to the 0 power, which is just 1, then 2 to the first power, which is 2, and 2 to the second power, which is 4, and 2 to the third power, which is 8. So every time we step 1, we're taking it times 2. And that's what logarithmic scales allow us to do. This is 2 to the 4th, 2 to the 5th, etc. So it's like 1, 2, 4, 8, 16, 32, etc. And we're just going to graph these numbers on this log base 2. And I could put some others in here, like this is 16 and 32. 32, 2 to the 6th, 2 to the 7th, 2 to the 8th. Now you have to remember the logarithmic scale, these are not linear in between here. Okay, so they're a little bit tough to kind of figure it out. So the easiest way to do it is just say 18 and rewrite 18 as 2 to some power, and then you know exactly where it sits on your logarithmic graph. Like if it's 2 to the first, you'd say, oh, it goes right there. If it's 2 to the second, it goes right there. If it's 2 to the 0.5, 2 to the 0.5 would be somewhere right smack dab in the middle of these two. Okay, and then to figure out what x is, so we'll know it's 2 to what power, we just take the log of both of these, log base 2 of the 18, and that just tells us what x is. Okay, or I'm just changing it to logarithmic form if you like. Okay, so I'm going to find out what the log base 2 of 18 is. So I'm just going to go log of 18 divided by log of 2. Using that change of base formula as I type it in. There we go. And it says 4.1, call it 70. This is 2 to the 4.1. And so 4.1, here's 2 to the 4, there's 2 to the 5th, 2 to the 4, 0.1 should be right about there. And I'm just going to keep doing these, and I'm going to do log base 2 of 3, and you can see me do it on the calculator. I'm just going to do log of 3 divided by log 2. That's my log base 2 of it. So it's about a 1.584. So I want 2 to the 1.5. So 1.58, right there, if you can see where I put that. Let's see here, and I'll just do a whole bunch of them. Now I'm going to use my math. I'm going to go to log. I'm going to change it to base 2. Now I'm going to do all of them this way. So type in my 7. This one is 2.807. Second enter, and I'll change my 7 to a 38. It's about 5.248. And second enter to pull it up again. I'll type in a 265. And it goes up to about 8.050. So let's finish graphing all these. I'll do them in blue so they're a little easier to see. Black Panther was 2.8, so 2.8 is right about there. Doctor Strange is 5.24, so 5.2, somewhere around there. And finally, Ant-Man, 8.05, so he's way out here. All right, then our last one, now we gotta go to base 3. So let's do all our base 3s in green here. So I'm gonna change all these now to base 3. So this would be 3 to the 0, which is just 1, then 3 to the first, 3 to the second, third, and the nice thing is when you're doing the exponents, you can just treat these in between here linear. Okay, because it is running linear with the exponents. So this does go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as long as you're just dealing with exponents. So let's do them in green here. I'll go second, enter. This time I'm going to change the base down here to base 3 though, and then I'll do my numbers again. So let's get rid of a few of these here. Let's start first one, 18. Uh, 2.3. Should I do this one? Change it to a 7 now. Change it to a 38. One, and finally we'll change it to a 265. 5.079, and then we'll graph those. So 2.63, somewhere right about there. At 1, right there. Oops. It's exactly equal to 3. 1.7, somewhere right around there. 3.3 and 5.07. So there we go, base 3. Label your axis and show your math. I believe that covers everything we need to do. We could label these things, but we won't. All right, and that takes care of our first review. If you have questions, please shoot me an email.